Let's look at some other examples here of solving multivariable linear systems, right? Systems with three equations and three unknowns. As we said in the previous video, the goal in solving a multivariable linear system, other than getting the final answer, is to try to break down this complicated three-variable system into a less complicated two-variable system, or try to isolate one of the variables if at all possible. Here we have x plus y plus z is equal to 6. There's my first equation. 2x minus y plus z is equal to 3. And 3x plus y minus z is equal to 2. Again, we want to make this system more simple. And we can do so by trying to eliminate variables. Well, taking a look at this, it seems like eliminating y's or z's is going to be a good option. And actually, we can recognize here that adding the second and third equations eliminates both variables y and z. Notice that we have opposite coefficients for y and opposite coefficients for z in the second and third equations. So we take those two equations and we add them vertically. 2x plus 3x, that's going to give me 5x. The y's are going to add to 0. The z's are going to add to 0. 3 plus 2 gives me 5. We are left with 5x is equal to 5, which allows us to solve for x. X is equal to 1. All right, so combining these second and third equations allowed us to eliminate two variables to solve for the variable x. Now, once you have your solution for one of your variables, don't be afraid to begin to substitute that back into your equations, right? If you know something, plug it in. We can now substitute the value of x into the original equations to create a system with two unknowns. Let's see how that works out. Well, if I plug in 1 for x into the first equation, I get 1 plus y plus z is equal to 6. And combining our constants, our like terms, we get y plus z is equal to 5. Substituting in 1 for x into the second equation now, we get 2 times 1 minus y plus z is equal to 3. Well, 2 times 1 is 2. If we combine our like terms and subtract 2 from both sides, we get negative y plus z is equal to 1. So plugging in 1 for x, well, what did that just do? That just generated a system of two equations and two unknowns. And what's the best way to solve this system right here? Well, we've got opposite coefficients of y. So if we add these two equations together, we are going to be able to eliminate y. Let's add them. Y plus a negative y, that gives us 0. Z plus z gives us 2z is equal to 6, meaning that z is equal to 3. And once you have solved for two of the variables, we can back substitute into either one of the original equations, any of these original equations, to solve for our third variable, y. And in this case, I think that this first equation here, x plus y plus z, is going to be the easiest equation to back substitute into. So that leaves us with 1 plus y plus 3 is equal to 6. 1 plus 3 is 4. If I subtract 4 from both sides of the equation, we are left with y equals 2. And we can write our final answer as the ordered triple, x comma y comma z, 1 comma 2 comma 3. And again, we can check our solution by substituting those back into the original equations. Plugging in 1 for x, 2 for y, and 3 for z will make each one of our original equations true. Let's try another one. Solve the multivariable linear system. Again, whenever you have multiple variables, think about ways that you can try to eliminate a variable. In other words, create a system that has fewer than three variables. Well, in this particular case, I see that my first equation has an x and my second equation has a negative x. By adding these two equations together, we can eliminate the variable x. X minus 2y plus 3z equals 9. There's my first equation. Plus my second equation, negative x plus 3y is equal to negative 4. Notice x plus a negative x, those are going to add to 0. Negative 2y plus 3y is going to give me y. 3z plus 0z's gives me 3z is equal to 9 plus a negative 4 is 5. y plus 3z is equal to 5. So this combination gave me an equation that had the variables y and z. Now I want to find another combination that also eliminates the variable x. In other words, create another equation that just has y's and z's. So if we want to find another combination that eliminates x, well, we do have some options here. I'm going to say, let's multiply the second equation by 2 and add it to the third equation. All right, we multiply this second equation by 2. If I multiply the second equation by 2, that's going to give me negative 2x plus 6y is equal to negative 8. I can then add it to the third equation, 2x minus 5y plus 5z is equal to 17. Negative 2x plus 2x, those are going to add to 0. 6y plus a negative 5y is going to give me 1y plus 5z is equal to negative 8 plus 17. That is going to give me 9. Y plus 5z is equal to 9. So we now have these two new equations that only have the variables y and z. Well, what we just did is we generated a system with two variables and two unknowns. And what's the best way to solve this system with our new equations? Well, if we look at it, we see that we have a y and a y in both of these equations. If we combine them using subtraction, we're going to eliminate y, right? We can subtract these two new equations to eliminate the variable y. Y plus 3z equals 5 minus the equation y plus 5z equals 9. Y minus y gives us 0. 3z minus 5z gives me negative 2z. 5 minus 9 gives me negative 4. Negative 2z is equal to negative 4. Therefore, z is equal to 2. Now that we have solved for z, we can back substitute to begin to solve for some of our other variables. Okay, back substitute to solve for y and x. Now, we could pick either of these equations that I have circled here in red to back substitute z into. That will allow us to solve for y, right? The numbers here in this equation are a little bit smaller, so we can back substitute into there. Y plus 3 times 2 is equal to 5. 3 times 2 is 6, which means that y is going to equal negative 1. And once we have z and y, we can back substitute into any of our original equations to allow us to solve for x. It doesn't matter which one we choose. It's up to you. I ended up picking this first one here, x minus 2 times negative 1 plus 3 times 2 equals 9. Negative 2 times a negative 1 gives us a plus 2. This is x plus 2 plus 6. 2 plus 6 is 8. X plus 8 equals 9, which means x is equal to 1. And there we have our solution, the ordered triple, 1 comma negative 1 comma 2. Now, if you're solving any of these systems with three equations and three unknowns, recognize that the way that I have done it is not necessarily the only way to solve the system. Okay, there are other combinations that are going to allow you to simplify your three variable system into a two variable system. So just because you don't do exactly what I'm doing doesn't necessarily mean that it is wrong. Again, the goal of taking a three variable system is to turn it into a two variable system or a one variable system and simplify it down, break it down, take this complicated problem and turn it into easier problems to begin solving.